So our lesson recording was corrupted, so this is just going to be very short and sweet. So 2014, 2011 I've asked you to do for homework. These are the answers, and if you're getting them right, you don't need to put them into class notebook. In lesson I asked you to do the 2019 question. It's 48%. That's the kick, the last little bit. So we see how we go. So in the question, the information that you want is we start off with 0.2 moles of BCl in 5 litres, and we have a Kc value of 0.22. And the thing that we're trying to find out at the very end is something new, the percentage decomposition into bromine and chlorine. So it's the percent decomposition of your bromium chloride. So if you haven't done the question already, you can pause and do it now, and otherwise we'll go into the solution. So your Kc value looks like this: 1 equivalent to chlorine, 1 equivalent to bromine, 2 equivalents of bromine chloride. From the information in the question for my initial line, it was 0.2 moles per 5 litres of bromium chloride, and as always I recommend you do the division now, and your products are going to be 0 and 0 initially. At equilibrium, because I have 2 equivalents of bromium chloride, it's 0.04 minus 2x, and my products are going to be x and x. So I put that into my Kc equation, and I get 0.22 is equal to x squared over 0.04 minus 2x, all to be squared. So the fact that I have both of these means I can square root both sides, and it gives me 0.469 is equal to x divided by 0.04 minus 2x. Now to get rid of this 0.04 minus 2x, I have to multiply both sides by 0.04 minus 2x. So that allows me to cancel these guys out. So I now have this top line here. I have to do the multiplication of the 0.469 by what's in the brackets, and this gives me 0.01876 minus 0.938x is equal to x. To get this 0.938x to the other side, I have to add 0.938x to both sides. So that allows me to cancel it out. So I'm now left with 0.01876 is equal to 1.938x, and to have x by itself, I have to divide both sides by 1.938. That allows me to cancel out this, and then I work out my value of x to be 0.09968. So my equilibrium line was 0.04 minus 2x. So this is how much of my bromium chloride has been lost at equilibrium. So to get the percentage decomposition, I'm putting the 2x over the 0.04, and that gives me 48%, and the question asked to the nearest whole number, so no decimal points here. So the other part that I wanted to show you in this video is the last version. So if we cannot square root both sides and we have to find x in some way, we have to rearrange it into a quadratic equation, and to do that we can use this minus b plus or minus the square root of b squared minus 4ac all over 2a, and this can be found in your maths tables. So you will have a positive answer and a negative answer always, and the rule is essentially you're looking for a small positive number. So sometimes you can, in your positive answer, you will have this small positive, and the other answer will be negative, so you ignore that. And on other equations, you will have something that is small and positive, but you will also have something that's large and positive, and you ignore this. So on page 136 of your book, we are going to have a look at the question that's in there. So the first thing is the Kc. So the Kc, when you write it, is going to be PCl3 square bracket Cl2 square bracket all over PCl5, and you have a value of Kc from your question which is 0.04. So then we go to finding out what our equilibrium values are going to be. So again, from our equation there's one equivalent of each of these. So our initial line from our question tells us that we have 1 mole in 10 litres, and as always I would suggest that you do the division now, and our products are always 0. Our equilibrium line is going to be 0.1 minus x, and our products are going to be 0 plus x. So then we fill in our Kc equation, and I now have x squared over 0.1 minus x. So there are no square roots, so I need to turn that into a quadratic equation, and to do that I need to multiply both sides by 0.1 minus x, and that allows me to cancel these out. So I am going to be left with 0.04 by 0.1 minus x is equal to x squared. I then have to complete the multiplication on this left hand side, so I get 0.004 minus 0.04x is equal to x squared. To get everything that's on the left hand side over to the right, I need to add 0.04x and subtract minus 0.004 to both sides. This makes these all cancel out, and then I am left with 0 is equal to x squared plus 0.04x minus 0.004. This is my a value, my b value, and my c value for my quadratic formula. So minus b plus or minus the square root of b squared minus 4ac all over 2a, sorry. Now I would suggest you put that into your calculator as it is and do one version where it's positive and one version where it's negative. And this is the point where people make the most mistakes in using this. So when you do that, you get two answers. So first answer is 0.046, and the second answer is negative 0.086. And we've said in the rules that you ignore a negative number or very large positive, so this is the number we are going to ignore. So our value of x in this instance is 0.046. Now I am going to erase everything up here so that we can do our ending. So we found our value of x, and now the last thing that we need to do is find the equilibrium concentration of our reactants and our products. So we now fill in what is x. 0.046, this is going to be 0.046, and this is going to be 0.046. So when we do that, we get 0.054, one answer, 0.046, 0.046, the other answers for the products. And that is how you use the quadratic formula. So you now have the 2017 and the 2015 questions as your examples to try and put into OneNote if you